Okay, for tonight's homework, it says, what is the thickness or height of your aluminum foil? And from your graph that we got in class, you should have gotten, for your y equals mx plus b, you should have gotten that m was around 2.61 grams per centimeter cubed. So that tells me that for every 1 centimeter cubed of aluminum, there is 2.61 grams of aluminum. Now, I don't know what your aluminum foil measured. Let's say that your aluminum foil measured 0.54 grams of aluminum. So now from this, we can say, all right, well, this is divided by about 5. This is divided by 5, so this would be 0.2. Now you're going to get a lot. Okay, so your numbers are going to be a lot better than my numbers here. So this now is my volume, and I know that the volume is equal to length times width times height. And the volume here is 0.2 centimeters cubed, and let's say that my length and width of my aluminum foil was, let's say, I don't know, 1 centimeter by 2 centimeters times my height. So now I can say, okay, well, this is 1 times 2, that's 2 centimeters squared times the height. So 0.2 centimeters cubed is equal to, well, if I divide these two sides, then I end up with 0.1 centimeters is my height. Okay, that would be a pretty bad height because I could tell that it wasn't 1/10 of a centimeter, but we'd get something there. So this next question says, if the actual height was 0.155317 millimeters, what was your percent error? So working from my last one that said it was 0.1 centimeters, well, I know that for every 1 centimeter, there is 10 millimeters. And if I have 0.1 centimeters, I'd have divided by 10, this would be 1 millimeter. So that would mean that if this is 0.1 centimeters from the backside, that would mean that in millimeters, that was 1 millimeter. So the actual height should have been this, which is really tiny, compared to this one. So I'm off by 0.9844683. So just by that many millimeters. So for every 0.9844683 millimeters, there should have been 0.015317 millimeters. So this is kind of like my part that's in error. This is my part that's in error here, and this is what the answer should have been. Now, it's really hard to kind of compare this, so what we usually do is we don't try to compare this against some random digit. We say, okay, what if this was 100 over here? Now, we're going to have a lot of percent error because this number is way far away from this one. So this is times 6,438. So this is going to be times 6,438. And you can see this number is pretty close to 1. So when I multiply that by the 0.98, I get 6309. So I'm off. If these were my actual numbers, I'd be off by 6,309%. Your numbers are going to be a lot better than that, I would think. Okay, and the last question here says, look, basically, you've got, if you think about the aluminum foil, right, you've got a length, width, height, and then you've got a really thin, a length and a width, and a really thin height. So you're going to be able to stack in some atoms, and each one of those atoms is 100, if we were to measure the diameter, it would be 184 picometers. Okay, and that's the diameter of this. So if I were to look at the radius of an atom, it would be 92 picometers. Okay, now an atom we're going to assume is a sphere. And so we know that the volume of a sphere is 4/3 pi r cubed. And you say, Mr. Swistak, pi are not cubed, pi are round. But we're going to assume they're cubed here. That was a joke. So this is the volume of a sphere of aluminum is 4/3 times pi times 92 picometers cubed. Okay? And we're going to actually convert this out first. So before we were comparing it to millimeters. So I'm going to say for every 1 millimeter, there is, well, I know 1 millimeter is 10 to the negative third, and pico is 10 to the negative 12th. So if I think about this, that means that there's 1 times 10 to the 9th, or 1 billion picometers in a millimeter. So we've got 92 picometers. So if I try to figure this out, or I could just figure this out. So to get from here to here, I'd have to divide by 10 to the 9th. So this would be divided by 10 to the 9th, which would be 92 times 10 to the negative 9th. So now we're going to say that the volume of a sphere is equal to 4/3 times pi times 92 times 10 to the negative 9th millimeters cubed. So this number comes out to be 778,688 millimeters, and that's times 10 to the negative 27th times pi times 4/3. So this is 3,260,107 times 10 to the negative 27th. And I could drag this back 27 spots, and I would come back 6 less. So this would be 3.26 times 10 to the negative 21st millimeters cubed. So it's a small sphere, and that makes sense because we can't see it at all. Okay, so now I'm just going to erase actually I won't erase, I'll just make that a little bit smaller. So now here is the number. So we said that it was 3.26 times 10 to the negative 21st millimeters cubed. And that's how much space each one of these little tiny aluminum atoms take up. That's why we say they're really tiny. We can't really think about them that way. So now we know that the volume of this, we said, was 0.1 centimeters cubed, and that's for every 10 millimeters, there's 1 centimeter, and so that means that for every 1,000 millimeters cubed, there is 1 centimeter cubed, because this would be 10 millimeters by 10 millimeters by 10 millimeters. So we're going to say this is 0.1. I'm going to divide by 10. So that comes out to be 100 millimeters cubed and 0.1 centimeters cubed. So we're going to say for every 1 aluminum atom, there is 3.26 times 10 to the negative 21st millimeters cubed of space. Okay, and now we're going to say, well, okay, well, how many aluminum atoms do I have in that little tiny piece of foil? Well, we said that took up 100 millimeters cubed of space. So basically, we're just multiplying by 3 times, well, this is 10 to the second, so that would be 23 zeros. 3 times 10 to the 23rd. So there are 3 times 10 to the 23rd aluminum atoms in that much space. Okay. So we said that that was 3 times 10 to the 23rd atoms of aluminum. And now it says, well, look, a bunch of this space is actually empty. So we're going to say that 30% is empty space, which means that 70% is used by aluminum. So let's focus on what's filled. So 70 used of 100. That's what that 70% of the space. Okay. Well, we said that this was assuming that we had 100. So we're going to say this is 3 times 10 to the 23rd atoms of space. And we know that only 70% of it was used. So we can say this is times 3 times 10 to the 21st times 3 times 10 to the 21st. So 70 times 3 is 210 times 10 to the 21st. Or 2.1 times 10 to the 19th atoms of space. Hope that helps. See you tomorrow.